Recall from the previous video that we applied Taylor's theorem to find out the power series representation of e to the x centered at 1, and it's right here. Now we have to find the radius of convergence of this power series, which means we want to know where will this series converge, okay, and what the radius will be. Now please recall that there are three possibilities, right, for a power series convergence, and they are, so one case is the case where the series only converges at the center, and in this case the center is 1, and so the radius will be 0 in that case. The second possibility is that the series will converge on the entire real line, so from negative infinity to infinity, and in that case radius of convergence will be infinity. And the third case is the intermediate one, that it converges in an interval of radius r, center at the center of the series, which is 1. So in that case the radius will be between some number between 0 and infinity. So question is, which of these three cases will happen for our series, right? Now also recall that given a power series, if you want to compute its interval and radius of convergence, you can use ratio test, and usually that works. So let us use ratio test. Okay, so remember we need to figure out an and an plus 1, and then form the ratio, find the limit. So an is already given, is the expression inside the summation. So it's e over n factorial x minus 1 to the power n. Now looking at an, figure out an plus 1, it's nothing but the next term. So wherever there is n, you plug in n plus 1. And that will be e over, now be careful, this is n factorial. So you are replacing n with n plus 1. So don't write n factorial plus 1, but write n plus 1 factorial. That's very important. And x minus 1 will also have the power of n plus 1. Okay? And now let's form our limit. As n approaches to infinity, remember to put the absolute value, it's very, very important. Absolute value of the ratio an plus 1 over an, and that is, okay. Now the an plus 1, that fraction, write it down as it is, because that is in the numerator. So you have e x minus 1 to the n plus 1 over n plus 1 factorial. And then an is in the denominator, so that fraction that you have, you just flip it and multiply. So you will have n factorial divided by e x minus 1 to the power n. And now see if you can cancel some things. Well, right away the e cancels, right? Okay. Now there are like terms, the x minus 1 terms in the numerator and denominator, and they will cancel. So let's see, x minus 1, there's an extra 1 in the numerator, n plus 1, and the denominator we have n many. So n of them will cancel, and you'll be left with just x minus 1. Okay, and then you have n factorial, let's write it down, over n plus 1 factorial. Okay, do you know how to cancel factorials? Do you know what n plus 1 factorial means? Let me show you right here. N plus 1 factorial is multiplying the numbers 1 times 2 times 3 all the way up to n plus 1. So it's 1, 2, 3, all the way up to n plus 1. All the integers, right? So what is the number right before n plus 1? It's n. So in the denominator we have all these numbers. So what is in the numerator? See, this first n terms, that is n factorial. So as you can see, the n factorial will cancel, and you will be left with the n plus 1 in the denominator. Okay, so let's write it down. So absolute value x minus 1 divided by n plus 1. Okay, be very, very careful at this point, okay? Look, the limit is on n. So n is the variable. X is not. X is constant. So you can pull out the constant outside the limit if you want. So notice further that the absolute value should be applied only to the x term, because x could be negative, right? Or x minus 1, this entire thing can be negative. But not on this n plus 1, because that's always going to be positive. So we don't need absolute value against n plus 1. And now x minus 1 absolute value is a constant. Pull it out. And we will be left with limit of 1 over n plus 1 as n goes to infinity. So what is happening? Denominator is getting big, so the whole thing is getting small. And that means this limit is 0. So this is equal to absolute x minus 1 times 0, which is 0. Now don't forget what we are doing, right? We are applying ratio test. And the limit turns out to be 0 for every value of x you plug in. It doesn't matter, right, what x you plug in. This is a number times 0. This is always going to be 0. So this is 0, which means this is less than 1 for all x, whatever x you plug in. And less than 1 means converges, right? So this means this series converges where? For which x? For all x. And what does that tell you? Which option is it? Converges for all x, everywhere, right? The whole real line is converging. So radius is right here. So the radius of convergence is infinity. So we have the power series expression of the function, and we know that this one converges for all real numbers. So radius is infinity. So that completes the problem. Thank you.